The year is 2057, the sunlight is fading, and the cold on Earth is continuously increasing. Sheets of ice are spreading everywhere, and the end of humanity is drawing near. Crops are dying, cities are becoming deserted, and the world is on the brink of a new ice age. Scientists believe that a mysterious particle called cobalt in the core of the sun is disrupting its nuclear fusion process. This is our last hope to stop the disaster. In Ares 1, a spacecraft carrying 8 astronauts loses communication with Earth after a massive solar storm. So no one knows what happened to it. Meanwhile, on Earth, the situation gets even worse. The entire planet starts to freeze. Almost 7 years after the previous mission, a new crew is launched. Yes, the captain of the mission that disappeared earlier is determined to sabotage this mission. This is the story of the 2007 science fiction movie Sunshine. But the question is, can this really happen? Can the sun die so soon? And if the sun really starts to die, can we humans save it? In today's thrilling journey, we will try to understand this cosmic mystery. What will happen to humanity if something abnormal happens to the sun? So get ready for a journey that will make you think. The movie Sunshine takes us to a world where the brightness of the sun is fading. The film shows that a theoretical particle called cobalt is stopping nuclear fusion in the core of the sun. In reality, we haven't found any solid evidence of cobalt so far. It's just a mathematical concept which is being studied in labs like CERN. The movie's scientific consultant and CERN physicist Brian Cox's idea helped the movie portray the struggle of enduring the sun's intense radiation. The crew members sent on this mission fall victim to psychological stress. And then the captain of Icarus 1, who is immersed in religious fanaticism, tries to sabotage the mission. The climax of the film leaves you with a question. Was the sun saved, and at what cost? But when we look at our real world, can a nuclear bomb reignite our sun? The answer is no. The sun. Every second, it produces as much energy as 386 billion trillion megatons of trinitrotoluene. Even humanity's most powerful nuclear bomb, the Tsar Bomba, is nothing compared to this. It was about 50 megatons. The difference is so great, it's hard to explain. The temperature at the core of the sun is around 15 million degrees Celsius, and the pressure in its core is so high that any bomb would vaporize before even reaching there. Actually, our sun is so huge that even if we wanted to reignite it, billions of our atomic bombs wouldn't be enough. But the main concern that comes to our mind from this movie is whether our sun really has a main sequence star like this. Which turns hydrogen into helium, generating energy. This nuclear fusion process has been going on for the past 4.6 billion years and will continue for the next 5 to 7 billion years. Today, if the life of the sun and stars comes to an end, it means that plants will die and 99% of life on this earth will be wiped out. About 5 billion years from now, the sun's hydrogen will start to run out and the sun will turn into a red giant, so big that Mercury, Venus, will become cold and a dead star. But in Sunshine, it's shown that the sun starts dying in 2057. Is this scientifically possible? The answer is almost not. The sun dying so quickly goes against natural processes. For this, some extreme collision or a gamma ray burst would be needed that could make the sun's core so unstable that it destroys itself. But the probability of any such event is so low that astronomers practically consider it zero. According to scientists, what would happen to us if something like this actually happened? The sun's brightness will eventually decrease, causing Earth's temperature to fall below zero in days. All the oceans on Earth will start to freeze, and without light, even photosynthesis won't be able to save us. The idea of a stellar bomb in the movie Sunshine is quite exciting as cinema, but it's scientifically impractical. If we also made a plan to reignite the sun like in the movie, we would need something billions of times more powerful than the core of our own Earth. Any material would be destroyed even before reaching there. In such a situation, the idea of reigniting the core seems completely imaginary. And even if somehow we reached the core of the sun, we would still need something billions of times more powerful. But is there any other way? There are some theoretical options for this. The first is stellar lifting. In this technique, hydrogen and helium are extracted from the sun's outer layer and injected inside to increase its fuel. These methods exist only in imagination. The second option is to build artificial fusion reactors and inject hydrogen into the sun's core. But the sun's core is so extreme, with temperatures of 15 million degrees Celsius and unimaginable pressure. Hardly any material could withstand it. It would melt before even reaching the core. Right now, even our best materials can't handle the sun's surface, let alone reaching its core. The third idea is to use high-energy particle beams or lasers to boost nuclear fusion in the sun's core. But for this, we would need an intense amount of energy, so much energy, So till today, we have never moved Earth to another star system like Proxima Centauri, which is shown well in the movie The Wandering Earth. But for this, we need light speed, propulsion, and generation ships. We would have to compress it so that its core heats up again. But even for this, we'd need a black hole level gravitational force, which is impossible. National Aeronautics and Space Administration scientists say that we have a lot of options, but we are not able to fully manage even the best one among them. We are not yet ready for stellar engineering on the Kardashev scale. If the sun suddenly starts to die, we won't have any time to do anything in such a situation. What would happen on Earth if the sun's luminosity suddenly started to decrease? Even though we've recently learned how to mimic the sun, we're still not advanced enough to engineer our own sun. If the sun's light starts to decrease, there will definitely be chaos all over the world. People will start trying to adapt to this mysterious change, but soon they will begin to realize that this is not a change that human civilization can survive. The temperature all over the Earth will start to drop rapidly, which will lead to a new ice age. If there is no energy, the Earth's ecosystem will collapse and the food chain will break right there. Crops will be destroyed and everywhere, animals and people will start dying of hunger. Even knowing that the world is about to end, people... How many resources do we have left to defend ourselves? If the scientists find any solution to survive this apocalypse, then the mission will be carried out with full dedication. And if there is any way to escape and survive this disaster, because it interacts with the solar wind, which will cause cosmic radiation to start leaking into Earth's atmosphere, putting the remaining life here in even more danger. But that will only happen when our sun actually starts to die and engulf everything. And even if Earth survives, its surface temperature will rise so much that it will turn into a hell like Venus. A toxic, scorching world where life is impossible. But in such a situation, somewhere the Earth's orbit shifted a little outward. But this will happen billions of years later. If somehow the sun starts dying in 2057, then we won't have any time to prepare for anything. What options will humanity have when the sunlight slowly starts to fade? If the scenario shown in the movie becomes the reality of our world, what options will humanity have? The shortage of food makes this a temporary solution. If we have to survive for a long time, we will have to find another way, and that way could be our space colonies. Self-sustaining colonies can be built on Mars or on Jupiter's moon Europa, but for this, we will have to develop technologies like closed-loop ecosystems, artificial gravity, and radiation protection. Currently, our space exploration is limited to Mars rovers and the International Space Station. It may take us decades or even centuries to build colonies. This shows why we need to grow our technology quickly, but building a space colony won't solve all our problems. No matter where we colonize in our solar system, as long as we don't have the sun for energy, our survival will be very difficult, and for survival, we will have to reach interstellar migration very quickly. If we can go to a star system like Proxima Centauri, then humanity can surely survive. But for interstellar travel, we will have to develop technologies like light, speed, propulsion, and generation ships as quickly as possible. But even if we can't do all that, it doesn't mean we have no hope. The energy we get from the sun, we will have to get that energy from somewhere else, which means we will need it. Alternative energy sources like nuclear fusion reactors or geothermal power plants could try to keep life going on Earth if the sun's energy runs out. Currently, our fusion technology is still at an early stage. Projects like ITR are still decades away. And if the sun has completely died, these solutions can only give us more time to stay on Earth. These can provide a permanent solution, and the most radical idea is the Dyson sphere. We would have to build a mega structure around the sun that can capture whatever energy is left from it. But for its construction, we would have to completely dismantle entire planets. We would have to use all of their resources. And to do that, we would need the capabilities of a Type 2 civilization. Right now, we are still Type 0, but among all these possibilities, the biggest challenge will be time. If the sun is dying slowly, we might have a few hundred years, but if there's a sudden collapse, we would have only a few years to a few weeks. To save our existence, our sun is not just a star, it's the foundation of our civilization. It gives us energy, controls the climate, and makes life possible. Without the sun, the Earth would turn into a cold, dark rock. The movie Sunshine gives us a warning about how fragile our existence is. Our technology, our intelligence, and our willpower all depend on that star. But this movie doesn't just scare us, it also gives us hope. Humanity has always faced challenges. From the discovery of fire to space travel, we have made the impossible possible. Maybe in the future, we will master stellar engineering too. Maybe we will build space colonies or achieve interstellar migration. But for that, we have to start working right now. Even though the sun won't die in 2057, that doesn't mean we don't need to be prepared. Will we be able to prepare for such situations in time? Or will we also have to burn in the sun's fire like Icarus's spaceship? In 2020, a Netflix series called Into the Night was released, and a similar series was also seen in 2022. Its name is Yakumo's S245. In these, our sun takes on a dangerous form. During its 11-year active cycle, the sun becomes dangerously active, and this releases a massive solar storm, which wreaks havoc on Earth. During the day, that is, in the sunlight, dangerous radiation pours down on Earth, causing people to start dying. Of course, both of these series are worth watching, but the question here is, can a solar storm really destroy the Earth? Has anything like this ever happened in the history of our Earth, or could it happen in the future? We'll find out in today's video. The sun is our only star. With the first ray of the sun, radiation starts reaching the daytime side of the Earth. In fact, it's because of this radiation that life is sustained on Earth and plants are able to make their food. The oceans also get their energy from this, and for us humans, the sun's energy is life-giving. This energy from the sun reaches the Earth in the form of radiation. That means the sun's radiation is necessary for us, but only in a certain amount. And this amount is controlled by our Earth's atmosphere. Our Earth's atmosphere filters the radiation coming from the sun, and it only allows as much radiation to reach the surface as we and the Earth need. But what if this radiation goes out of our control? Armaton charged solar material? What if all of a sudden it starts heading towards our Earth at thousands of miles per second? What if our Earth gets directly hit by a solar flare? Will this planet be able to save us? The answer is a bit complicated, but all scientists completely agree that our Earth's magnetic field and atmosphere protect us from even the most powerful solar outbursts coming from the sun. However, even then, these solar storms can destroy our radars, radio systems, and even the satellites orbiting in space. But it can't even touch us after reaching the Earth's surface, and this is only and only because of our atmosphere. Believe me, we live on the luckiest planet in this universe, Earth, which has an atmosphere that doesn't let any of the dangerous radiations from solar flares reach us. According to Alex Young, Associate Director of the Heliophysics Science Division at National Aeronautics and Space Administration is Goddard Space Flight Center, in the last 10,000 years, no matter how big the solar events have been, there has never been a time when Earth's atmosphere was damaged or Earth became unsafe to live on. Although in 2012 there was a lot of fear among people regarding solar flares, nothing happened at that time either. However, it's not that solar flares have never caused destruction on Earth. Earth's magnetic field protects us from the devastation caused by solar radiation. But the electromagnetic power of these flares is so strong that it can destroy power grids, internet connections, and other communication devices. This can cause chaos everywhere and even lead to people's deaths due to these reasons. National Aeronautics and Space Administration, space weather experts, and other space agencies see this as a serious threat. That's why the sun and its activities are closely monitored. So, what exactly are solar flares? Solar flares are formed when the sun's magnetic field lines collide with each other or get twisted. This creates an enormous storm, the size of a planet, which is released from the sun's surface in the form of electromagnetic energy. We can see these storms on the sun as cold and dark patches, which we also call sunspots. Around these sunspots, there is a large spread of magnetic field lines where they are tangled with each other. Sometimes they get twisted and sometimes they collide with each other, which releases a powerful flash of energy. And along with that, a lot of material, meaning charged particles, are also released from the sun, which we call solar flares. Most of the energy from solar flares is released in the form of ultraviolet and X-rays light. Because of this, the gases present in the sun's atmosphere also get heated to very high temperatures, and that's why a large amount of charged particles are released from the sun's atmosphere into space. These are called coronal mass ejections, CMEs. If a sunspot blasts a coronal mass ejection toward our Earth, that massive storm can reach our planet at a speed of thousands of miles per second, arriving in about 15 hours or sometimes in a few days. Now, whether you've heard about CMEs before or not, it doesn't matter, because the sun keeps emitting these CMEs somewhere almost every week or even every day. That means it's a normal process for the sun, although during the 11-year activity cycle, the number of CMEs increases along with the sun's activity. Most people don't notice CMEs. They just pass by this planet because Earth's magnetic field protects us, but very large and energetic CMEs actually compress our planet's magnetic field. This is why we see geomagnetic storms on Earth. What happens is that the electromagnetic energy coming from the sun fills up our magnetosphere. The atoms and molecules present in Earth's atmosphere become electrically charged. Because of this, something happens that we can see all over the world. Because of such storms, the auroras borealis that we see near Earth's North Pole will also become visible at the equator due to a very large storm. If such a massive solar storm hits our Earth, the entire world's radio and radar systems will be completely blacked out. Electrical grids will become overloaded due to the power surge, which could also cause blackouts in the power grids. Even if that doesn't happen, long power cuts will become a common thing. Some experts are even afraid that a major coronal mass ejection storm could cause an internet collapse on Earth. There could also be overloading in our internet cables laid under the sea. And if that happens, our world will come to a complete halt without the internet. Although this has never happened before, the possibility cannot be ruled out. And if that happens, the internet could disappear from the entire world for weeks or even months. Our space stations and satellites will also not be able to withstand the impact of CME's radiation because they do not have the protection of Earth's atmosphere and are completely exposed to the harsh environment of space. The most powerful geomagnetic storm ever recorded in Earth's history was documented in 1869, which is known as the Carrington event. However, this most powerful geomagnetic storm did not have any significant impact on life flourishing on Earth, humanity, or human health. If an even bigger storm than this ever occurred in Earth's history, we have not yet found any evidence that it affected human life. So, one thing is clear. No matter how strong a solar storm is, life on Earth will continue as usual. We don't know how big a solar flare would have to be to wipe out life on Earth, but it has never happened in history. Or it could also be that no solar flare can ever wipe out life on Earth. But there is another enemy that can wipe out life from Earth in the blink of an eye. And this has actually happened once in history, and that threat is the stars around us. When a star uses up all its fuel and reaches the end of its life, it explodes as a massive supernova. This releases intense radiation that travels millions of light years through space. These blasts are much more powerful than any solar flare. The ultraviolet radiation released from them is what affects our Earth. It is claimed that during the end of the Devonian period, around 416 million to 358 million years ago, about 64 light years away from Earth, a star died. That star exploded into a supernova, which caused mass extinction here on Earth. What caused the mass extinction? So what were the factors that triggered this mass extinction? However, studies of the skeletons from that mass extinction period revealed that their fossils were damaged due to ultraviolet radiation, which could only happen because of an exploding star or a supernova. But fortunately, there is no such supernova candidate present near our Earth that could pose a threat to us in the near future. Only our small star, the Sun, is there, which currently cannot become a supernova. And as for the solar storms coming from it, our Earth's atmosphere is enough to protect us from them. Like the Netflix series Yakumo S245 or Into the Night, we might never have to see such days. Imagine a celestial body that is very large, very powerful, one that even from a distance of 93 million miles is controlling life on a planet in every way. And now imagine that the body responsible for life on a planet is also hiding extremely deep secrets. Secrets that even scientists can't fully explain. Yes, we are talking about our sun. We think we know the sun, but do we really know it? What if I tell you that there are forces brewing inside the sun that could wipe out all of human civilization in the blink of an eye? That familiar warmth we feel every day, we haven't even realized or understood the destruction it could cause. From the strange sunspots visible on its surface to the dangerous solar storms, the sun is not just a life-giving deity as we think. It's also a ticking time bomb that can explode with unimaginable force at any moment. So in this video, today we'll explore the dark side of our sun, which is unpredictable, violent, and extremely mysterious. After this, your perspective on the sun will change. From ancient civilizations that considered the sun a deity, to today's modern science, which now sees it as the engine of life. Although we know that the sun is a huge ball of gas and plasma, but if we look at it on a broad scale, life truly isn't possible without the sun. And humanity has known from the beginning that the sun is essential for us, but at the same time, that very sun is one of the most dangerous forces in our solar system. Apart from its warmth and familiar light, it's an uncontrollable cosmic nuclear furnace that is constantly leading us toward a major event. We take the sun for granted, which in this endless universe lights up the planets like a giant lamp. It keeps them warm and also sustains life on those planets. If we go deep into the sun, the gravity there is so intense that even hydrogen atoms collide and fuse together. Through this process of nuclear fusion, the entire sun is able to release an immense amount of heat, and in this way, the temperature of the sun's surface reaches up to 5,500 degrees Celsius. But the real terror is hidden in its core, where the temperature reaches up to 15 million degrees Celsius. 15 million degrees Celsius. This is beyond our imagination. This immense energy of the sun not only gives us light, but it also creates storms on the sun. There is also a massive ejection of magnetic fields and charged particles there. Even though solar flares and solar mass ejections may not seem very dangerous to us, but they have so much power that they can destroy our modern technology in an instant. A single solar storm can push us into a global blackout. To be honest, we are literally living at the mercy of a star, which can change its course at any time, and the scariest thing is that it neither knows us nor is it compassionate. So let's take a look at a dangerous example of the sun's power. A solar storm. In 1869, a massive solar storm was released from the sun, which we now know as the Carrington event. This solar storm was so intense that the telegraph system of that time was completely shut down. Equipment caught fire, and the operators working on those systems and equipment receive strong electric shocks. If such a storm hits the Earth today, destruction is certain. Our modern world is highly dependent on technology. The result will be that the internet, global positioning system, power grids, and satellites will be fried within moments. These are the main resources where its impact will be most visible. Apart from this, people traveling by sea and air will get stranded in the middle of their journey. There are also some devices in our body that can conduct electricity. In this situation, the risk to people and property will rise greatly. A large amount of magnetic energy is released from the sun's atmosphere, and this explosion is called a solar storm. Solar storms can send highly charged particles into space in any direction, and when they come towards the Earth, they move towards it at a speed of millions of miles per hour. When this storm hits the Earth, it interacts with its magnetic field. Because of this, we see beautiful auroras in the sky, but behind this beauty are these terrifying solar storms that can destroy everything in an instant. The scariest thing about this is that we can't see them coming. Solar storms erupt without any warning. One moment the sun is completely calm, and the next moment it can release this invisible, dangerous radiation toward us. The Carrington event was a warning for us, but we have come a long way by learning from this event. For decades, space agencies and scientists have been constantly monitoring such solar storms on the sun so that we can protect ourselves from them in time. The question is not whether the next solar storm will hit us, but rather when will it happen. This uncertainty always keeps us afraid. The sun has another dark side, sunspots. When we look up at the sky and see the sun, we see its dazzling, blinding brightness, but it doesn't always shine like this. Sometimes we can also see dark spots on its surface, which are called sunspots. These are cooler regions on the surface of the sun where the sun's magnetic fields are twisted and tangled together. We have been observing sunspots for centuries, but the reason for their formation has always remained a mystery. But what we do know about them is that wherever sunspots appear, destruction follows. Sunspots are linked to the activity of our sun, and sunspots are also the root cause of many intense solar storms. These dark spots indicate some terrifying processes happening inside the sun, which we still haven't been able to understand. But why do they form, and why do these sunspots trigger solar flares and coronal mass ejections? These questions still remain. And the more sunspots there are, the higher the chances of solar flares become. That's why during the sun's 11-year activity cycle, we see more solar flares and increased solar activity. But we also have to remember that we live peacefully under the shelter of a star that is not peaceful at all. But sunspots are not the only danger coming from the sun. The sun has another dark side, solar flares. Solar flares are the sun's way of releasing suppressed energy. And when these flares erupt, the energy released from them is even greater than the energy of millions of atomic bombs. Solar flares release radiation and charged particles in every direction from the sun. And sometimes they come directly toward our Earth. When a powerful solar flare hits our Earth, the effects can bring our entire world to a halt. A global blackout, disappearance of global positioning system signals, malfunctioning satellites, power grid failures, and the entire internet economy ecosystem could all come to a standstill. Just from a single flare hitting us. The banking system, aviation industry, and all other sectors that rely on the internet will suddenly come to a halt. The risk is increasing. But even now, there is still so much about the sun that we haven't been able to understand. For example, the sun's corona. The biggest mystery about its outermost layer, the corona, is that its temperature is much higher than the surface of the sun. How is this possible? The sun's surface reaches 5,500 degrees Celsius. How can the corona, located hundreds of kilometers away, reach millions of degrees Celsius? Another mystery is, what force is driving the solar cycles? Every 11 years, the sun's magnetic poles flip, which increases solar activity. But scientists have not been able to figure out the driving force behind this. It gives us a glimpse of that, and from this, we get to know how much we actually understand this infinite universe and where we really stand. The sun is our closest star, but this universe is infinite, and such mysteries make this universe even more fascinating. Because in this universe, everything follows the rules set by the universe itself. And maybe it's better if some mysteries remain hidden forever. If someone named Sabita learns every secret of the universe, she will become the supreme leader, and she will want to run the rules of the universe according to her own will. And maybe none of us would want that. So friends, what are your thoughts about the mysteries of the sun? Do let us know in the comment section. If you like this video, make sure to like it and share it with your friends. For more such informative videos, subscribe to the channel and enable the bell notification. Friends, we'll meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.